JavaScript for enterprise development. Building enterprise applications with the magic of React, Redux, and GraphQL. With Rizchel.
Okay, cool. So hi everyone, I'm Rizchel, and today I'm going to be talking about building enterprise applications with React, Redux, and GraphQL. So a little bit about me. Again, my name is Rizchel. Currently, I'm a cloud services engineer, and I focus on the front end at Gatsby. I just started in January, so I'm pretty new, but I'm excited about it. But before, I was previously a front-end developer lead and developer advocate at IBM, and that experience is what I'm going to be talking about today, how we built enterprise applications there, and hopefully you guys can get something from what I'm going to share. So building enterprise applications from the ground up is terrifying. If anyone else says it's not terrifying, I don't know, but basically I was given a project to lead the front end for the IBM Cloud, for one of the microservices within the IBM Cloud. And for me, it was really kind of scary at the beginning. You know, I knew kind of the tools we wanted to use, but then you have to think about architecture, you have to bring in other parties, stakeholders. So when you're kind of starting this journey, it can just be really scary and kind of daunting. And at first, when you think about it, the application seems more like this. You think it's kind of self-contained. So especially since we were working on the front end, we'd have to work a little bit with the back end and DevOps and everything. But you're like, okay, this is a self-contained microservice. It's a small piece within a big ecosystem. So the IBM Cloud has a lot of services, and there's a lot of people working on it. So you think it's a small piece within this ecosystem. It's kind of easier to kind of grasp. That's not like this huge thing. And then usually it serves a single purpose. So I'll kind of go through later on what our purpose was. But at first, kind of getting this understanding of it, it's easier to get the your head wrapped around this idea. And then when you start digging into it, it kind of seems more like this. So it's constantly shape-shifting. So I think on any project, requirements change, designs change. You can get, kind of curveballs out of the blue. So it's constantly shape-shifting. You're always having to change and you're always having to pivot. It serves multiple masters. So if you have multiple stakeholders, they're all going to have different metrics that they need to complete or get to. And as a developer, your job is to create a good experience and a good code base for them to kind of reach those goals and those metrics they want to. But when you're getting it from multiple people, it's kind of hard to prioritize what you need to focus on and kind of that kind of stuff. And then it starts getting huge and not well behaved. So this is kind of where the monolith comes from. At first you have a small application and then you just keep building on it. And then it all of a sudden becomes like monolithic and you're like, how did this happen? But while you're building it, you really have to think about, how do I not let it get to that point? So as an architect, sorcerer, or sorceress, you need to kind of embark on this journey to train the mighty dragon. So the mighty dragon in this case is whatever application that you're trying to build, but you need to train it, to be able to do the things that you want it to do and it not get, too crazy or too overwhelming where it's just hard to work with and hard to build a good experience. So the three things that I personally learned from IBM that were kind of really a big point with getting that victory, with getting that good experience and hitting those metrics that we needed to from stakeholders was one, teamwork. So without teamwork, you can't do it all yourself. So you need to be able to rely on your other team members. And I was a lead in this project, but I did rely heavily on the front-end developers that I worked with because, there was some areas that they were probably more experts on than I was. Maybe they had more experience with it. So I wanted to rely on their feedback and kind of everything like that to make sure that we created a project that we could all be proud of, and also working with other cross-discipline teams. Utilizing tools. So in technology, we have a lot of tools at our disposal. I think the big thing is knowing which tools are best for your application. There can be some amazing tools that don't specifically work for what you're needing it. And then there's obviously some that are. And then so utilize the tools that you need, but don't rely too heavily on them. And then last is gaining skills. So with any project, you're probably going to need to gain a new skill. Maybe it's a new technology, maybe it's a new tool, anything like that. You're always going to need to continuously learn. And then by gaining those skills, you can apply those skills, in your next project or just become a better developer. So the first step in this is know your dragon. So your dragon, again, is your application. So you need to define what your application needs to accomplish and excel. And that could be anything. So you kind of need to define what you want to accomplish in this. So our dragon was that we needed to improve an existing user experience and code standard for our virtual machine ordering flow. So within the IBM Cloud, we acquired SoftLayer a few years back now, but that basically meant that a lot of their infrastructure products came under the IBM Cloud umbrella. The problem was that basically it looked like two platforms rather than one unified platform. So you'd have SoftLayer, you'd get to SoftLayer through one login, you'd get through IBM Cloud in another login. So from a user, they couldn't really tell that it was one product. So what we wanted to go in was start unifying this experience, get these flows within IBM Cloud, and then also create like a good code standard for them. So here you can see the screenshot, which I hope it's not too small, but this was the original flow to order a virtual server, which is a virtual machine within IBM lingo. It's called a virtual server. But here you can see that there's like a bunch of sections that you need to open up. And then like some sections you had required, but if you scroll down the screen, you couldn't see that. And then it also started creating this list of stuff that you were ordering. And it just wasn't a really good experience. It was really confusing. So that was kind of the first big thing that we wanted to go in and make better and just create a better experience for our users. So this was the design that we had for what we were going to create. So this is within the IBM Cloud now. And here you can see it's still, since ordering a virtual server isn't easy, it still has a lot of different pieces to it. But we also had popular flavors. So you could, instead of having to configure every little thing, you could get kind of the packages. So we wanted to make it a better experience. And this is the new design that we were going for. So this was how we defined our dragon. So we met among the engineering team as well as our stakeholders. So we wanted to create a more user-friendly UX. We wanted to improve performance. So the performance wasn't very good because you had to call a lot of APIs on every time you came to this form. So it was really slow. We had some of these requirements were kind of forced on us, but we had to integrate multiple APIs, so SoftLayer and IBM. And then we wanted to create a standard for future microservices. So we kind of did a lot of the groundwork where other teams could kind of just clone our repo and then go from there. And it had kind of all the configuration and base things that you needed for microservices. Unify IBM Cloud Platform. And then we wanted to increase conversion from 2.5%. So that conversion comes from when someone went originally to that virtual machine ordering page, only 2.5% were successful in ordering an actual virtual machine. So it was really low. So we obviously wanted to increase that conversion. So the next one, kind of like choose your wand. So this is what creates all of your magic and your biggest tool. So for us, it was React. So we use React, ES6, Express, and Webpack, but I'm going to be focusing on React for this particular section. So what is React and why did we use it? So I think React is pretty popular now. A lot of people are using it, but I'm kind of just going to define how we define React. So it's a JS library for building user interfaces. It functions as the view layer. So when you think of a model view controller architecture, it really focuses on that view layer. The virtual DOM. So this is what I think makes it powerful from kind of like a performance perspective, but basically what the virtual DOM is it's an abstraction of your DOM. And when the UI makes any changes, it's only going to re-render the changes. It's not going to re-render the whole page. So that can be really powerful. Reusable components. We were using Carbon, which is the IBM component library. So it made sense that we kind of had to do reusable components. And then we also used Redux state management, which I'll go over a little bit more in the next slides. And then Carbon components, which I talked about earlier. So the architecture. So since we were creating a microservice within this bigger ecosystem, kind of the biggest application was the IBM Cloud. So this had front-end microservices, back-end microservices, you know, kind of the DevOps flow, everything like that. Then we had the microservice. So this is a loosely coupled service. So for us, it was a virtual server, but this could also be like an account page, anything like that. And then we did containers. So this is how we architected our kind of React components, was we had containers that handled all the data and it rendered all the subcomponents. And then the components were dumb reusable elements. So it had no logic tied to it. It was basically components that you could reuse in multiple parts of your application. And because there was no logic tied to it, that was easier to do. So React containers. So this is made up of a smaller part called components. It's kind of confusing because containers are components. It's just kind of the parent of a component child. It manages the state. So, you know, in your React components, you usually have to manage some sort of state in some of them. So your containers would manage the state rather than your components. It triggers Redux actions to update global state. So we were using Redux. This is where they were triggered. And this would also apply if you were using, you know, GraphQL to do queries. This is where all of that would happen. And then it passes data down as props to components. So if you have a query, let's say you're getting a user profile. If you have a GraphQL query getting a user profile in your container, you would make that query. And let's say if one of your components just needed the name, you would pass that name down from your container to your component, and your component would show the name. So this is an example. This obviously isn't from the IBM Cloud because I couldn't show that, but I did kind of a workshop that was around the same idea around Pokemon. So this is an example of a container. You know, you have your data, and this is just mock data, but let's say you were querying this from GraphQL. This is where all that would happen. And then here you can see I'm going through my mock data and I'm returning a card component. So this is the container, and then the card is what's going to be the component. And you can see I'm doing all my logic in here and just passing down like the Pokemon name, Pokemon object, and styles. So React component. So these are reusable elements. Again, since there's no logic tied to it, it's easier to use these elements anywhere within your UI. It receives data and state from the parent containers through props. And basically it just takes that data and then it renders it to the user. And then it doesn't handle any data manipulation. And it's purely presentational. So here's an example of that card component. So from before, my container, I pass it down to my card. So you can see here, it's just taking that as props and then just showing it here. I hope everyone can see this. It might be a little small, but yes. So you can see here that's just passing down and it's just gonna show the user that information. One thing about the styles, this isn't how we did it in IBM. We used SAS and had a different styling folder and styling files, but just for the purpose of this workshop, it was easier to pass them down rather than set up SAS and everything within that environment. So why do this? So a separation of concerns allows an application to be easier to manage and provides cleaner code. So that means that when you go in and you need to debug something, if it has something to do with data, you know it's going to be in container. If it has something to do with, you know, more of a elements or how they are styled or anything like that, you know it's going to be in a component. And you can take my word for this, or we actually did it the opposite way. We had our containers have no logic and our components have all the logic. So that started getting really hard to debug and just kind of sift through. So that's why we went with this architecture. We kind of went through trial and error, and we were like, this is not the right way. This makes it really complicated. So for us specifically, this worked out really well because we tried the other way and that just didn't work. So choose your spell. So this will like bind all your magic. So this is just like another tool in your utility belt. So we used Redux. So I know some of you are probably thinking like GraphQL and Redux. GraphQL has caching. Why would you use Redux as well? And I'll kind of go through that through this section, but if you have any questions, I'll take them at the end. So what is Redux? So it's a JavaScript library for managing global state. So if you need to share state between multiple of your components, Redux is really good because you don't have to pass state down through props. And let's say if you had nested components, if you have to just keep passing props, that can get really complicated. It has a strict unidirectional data flow. So it always has to go the same way every time. It can't go the other way. It's always going in one direction. It handles large amount of changing data. So that's where I think Redux is really powerful, because if you have a lot of data, it's really helpful. If you don't have as much data, Redux is a pretty big library, so it wouldn't make sense. But it's really powerful if you have large amounts of data. And then you basically use it when your container internal state is not enough. So if you have a large amount of data, you don't want to store that all in like a component internal state. That's just kind of too much. So the first thing in Redux is actions. So this basically triggers, it basically says that something has happened. So for example, if a user clicks a button, that would be an action. The action would be like user clicked button. And then you have your reducer. So this is how the state will change. So you have your initial state, and then you're going to have what would be your next state. So if someone has clicked a button, let's say you changed, a certain color or something else on the page, it would basically say that this state has moved from this initial state to this next state, and that's what's happening in the reducer. And then the store is where all of your data is stored. So that's kind of, it has all the states within, or all the global states within your application, and that's all going to be within the store. So actions, again, trigger the flow to send the data to the store. It described what happened. It has, so what an action is it's an object that contains the type of action performed. So let's say button click and any other information you want to pass. So if you want to say button clicked, and if you want to share the information of the next state, you would have it in your action. And then it's often dispatched from the container. So again, reinforcing that idea that containers have all this logic. So here, for example, is you're exporting the add Pokemon. That's going to be your action, the type. So this is add Pokemon. And then for this example, you're just passing in the whole Pokemon object. So reducers specify how the app state changes in response to action sent. It's a pure function that takes the previous state and the action, and then it returns the next state, which I'll show you that code in the next page. So here we can see some of this is like boilerplate stuff that you need to do for it. But at the top, you can see that our state is an empty array, and it'll take an action. And depending on the action type, it'll return the next state and the data. So the store holds all the application state, contains events that can update the state, get the state, or anything like that. So if you need to get a specific state from the store, that comes from the store. That event comes from the store. If you need to update the store contains that event. That's kind of confusing, but it's immutable. So you always have to go through that action reducer store flow. You can't, directly change the store. So this is an example of kind of how to set up the store. So you have a create store from Redux, and then you basically pass in your root reducer that I showed you in the previous slide, and that's what creates the initial state, and the reducer is ready to consume those actions and then spit out the next state. And then you basically just wrap your whole app with this provider, and then that'll give any of your components within your application access to the reducers, to the actions, and the store. So choose your potion. So GraphQL. So specifically, we use GraphQL for this. What is GraphQL? It's a query language for APIs. It allows the client to ask for only what it needs. So I really like that because let's say if you have an account API, but you only need the name from the client side, you could say all I need is the name, and that's what you're gonna get back, rather than getting all the data and having to sift through that on the client side. It's really nice that you could just get what you need. You can retrieve many resources in a single request. So if you're needing data from, a database and a third-party API or anything like that, you can get all of these resources in one request. So this is an example. So on the left-hand side, you can see that's your client side, desktop, mobile. And then in the middle, you can see your GraphQL server right here. And then you have, let's say, a legacy system of data, a microservice, and a third-party API. So if you send one request to your GraphQL server, it can get it from all of these different stores or data stores, and then return it within one request. So that's nice that you can do it all in one request, rather than usually you'd probably have to do this in 3 requests. So we used Apollo Client for it. So we built UI components that fetch from the GraphQL server, which I'll show you how to do that in the next slide. It's language agnostic, so you can use Apollo Client with any language. You don't have to use like a specific one, which is nice. And then it caches your query results. So if you make a query for getting a user, it'll cache those results. So on subsequent pages, if you need that same information, you can get it from the cache rather than make that query again. So it's really good for performance. And then it supports local and offline development. So if you want to use like mock data, maybe you don't have access to the internet or something like that, you can work on it in an offline experience as well. So this is an example of setting up the Apollo client. So here you can see that I'm creating an Apollo client with a URI. So this is just the GraphQL server for the Pokemon. And then I just wrap my component with the Apollo provider, and then they basically say this is where the client is. And then everything below that, everything that's contained within that component has access to any of your queries or mutations that you make. So queries are data fetching, so you can think of it as more of like a get call. It asks for specific fields on your object. So again, if you only want like the name, you can ask just for that specific field. And then it's interactive. So if you change a query, you can get a different result. So anytime you're using queries, if it changes anyway, you can get that instantly. So this is an example of a query for the Pokemon again. So we have, we import query from Apollo Client. We make this query. So here, I'm passing in, I only want to get the first 100 Pokemon and give me the number, the name, the image, and the types. And then you're going to have loading, error, or data. So if it's loading, return, just your Pokemon are loading. If there's an error, return the error. And then if there's not, pass this Pokemon information to your card component. So this is similar what I showed you earlier. This is just real data rather than mock data. And I'm going to try and hurry up because I know I'm running out of time, so I might go through these last ones a little quick. But mutations, so this is modifies your server-side data. So you can think of this more as a post call. It's similar to the query, except it returns an object type if it's available, if your API or your mutation returns a object. And then you can get the new state after the mutation. So if you're updating a user photo or something like that, you can get that new state after your mutation. So here you can see, for example, on the right-hand side, the mutation. So the mutation is submitting a repository. You pass it the full name of the repo. And then this is kind of the object you get back. You'll get created at. So you pass this down into your component, and then you pass in the variables, and then on click, that mutation will succeed or fail. So for IBM Cloud specifically, we came up with a microservice called Gramps. So we basically wanted to have a way to have basically a GraphQL microservice that any of the front end could consume, but then they were responsible for maintaining that, which I'll kind of go over in the next slides. So there was 4 different areas, which are models, resolvers, schemas, and mocks. And just because of time, I'm not going to go into detail into these, but the link for the repo is at the end at the resources. So what this allowed us to do when we created this GraphQL microservice, it was a central GraphQL microservice that anyone could consume. So any front-end microservice could consume this. And it was an isolated data source for each microservice. So let's say for the account microservice, they would have their own isolated GraphQL instance for any of the data, for any of the queries and mutations they needed. So rather than having IBM Cloud data source for everything, it allowed us to make that more modular, so it was easier to maintain. And it was easier adoption. So if someone doesn't have to set up a whole GraphQL server and all this kind of stuff that goes with it, since we just provided that as a team, people were more likely to adopt it and create their own data sources from it. And it had light maintenance. So because we didn't have to, our team didn't have to manage all these different data sources, it was a lot easier to have, over time. So from all of this, we increased conversion by over 250%. So again, at first that conversion was 2.5%. We increased it by over 250%. So that made us as a team happy because that directly correlated to the experience. That made our stakeholders happy because it was more money. So it was just like a win-win for everyone. And we also created a standard for future teams to follow. So we created like a microservice boilerplate that other people could consume. And we basically created, best practices that we thought as a team that other people could follow as well. So we trained the Mighty Beast. So our Mighty Beast was that virtual server experience, and we did a good job with it. So this is a quick recap of kind of what I talked about. So splitting out your components and containers, using GraphQL to help with performance, and then Redux for handling global state and external data storage, and then just testing and reviewing everything. So thanks for coming to my talk and hearing me. If you have any questions, I'll look in the chat to see if there's any questions there. But you could also find me at Rizchel Deo, basically on any social media site. And then you can also email me.
Thanks for watching.